In the autumn of 2017, a telescope in Hawaii spotted something that had never been seen before, an object that had come from beyond our solar system, from the space between the stars. It was moving too fast to belong to our sun, on a path that could only mean one thing, that it had fallen in from interstellar space, passed briefly through our neighborhood, and was already leaving, never to return. We had 11 days to study it. And in those 11 days, it behaved so strangely that scientists are still arguing about what it was. Its name is Oumuamua. This is the story of the first known visitor from another star system, a mysterious, elongated object that tumbled through our solar system, accelerated in a way it should not have, and then vanished back into the dark before we could get a proper look. It is a genuine cosmic mystery, one that touched, briefly and controversially, on the greatest question of all. This is Deep Field. On the 19th of October, 2017, an astronomer named Robert Warwick was reviewing images from the Pan-STARRS telescope on the summit of Haleakala, in Hawaii, a survey designed to hunt for asteroids and comets. Among the usual objects, he found a faint point of light behaving very oddly. When its orbit was calculated, the result was astonishing. This object was not on a normal looping orbit around the sun. It was on a hyperbolic path. At first, no one knew quite what they were looking at. The object was initially logged as a comet, then reclassified as an asteroid, as astronomers struggled to make its numbers add up. It was faint, and it was fast, and the more they measured it, the stranger its motion became. Only when its full trajectory was pieced together did the extraordinary truth become undeniable. This thing had not come from anywhere in our solar system at all. That word, hyperbolic, is the key to everything. Objects bound to our sun travel in closed ellipses, going around and around. But Oumuamua was moving too fast, on an open, one-way trajectory. It had not been captured by the sun's gravity. It had simply fallen in from outside, whipped around the sun, and was now climbing back out, headed for interstellar space forever. It was, unmistakably, a piece of another star system, passing through ours. The speed told the story. At its fastest, near the sun, Oumuamua was traveling at tens of kilometers every second, far too fast for the sun to ever hold on to it. Trace its incoming path backward, and it came roughly from the direction of the constellation Lyra, from the great star fields of the Milky Way, though not from any single identifiable star. It had likely been wandering the galaxy, alone in the dark, for many millions of years before stumbling into our sun's grip. This was a first. Astronomers had long assumed that such interstellar wanderers must exist, cast off from other planetary systems and drifting between the stars in unimaginable numbers. But none had ever been caught in the act of passing through our own solar system. Oumuamua was the first. It was given a brand new classification and a Hawaiian name meaning, roughly, a scout or a messenger from far away arriving first. The scout had come. To mark the occasion, astronomers created an entirely new category. Objects that orbit the sun get familiar labels, but Oumuamua needed something unprecedented, a designation with the letter I for interstellar. It became, formally, the first interstellar object ever cataloged. After centuries of tracking comets and asteroids born in our own system, humanity had finally logged a genuine visitor from another. But almost immediately, Oumuamua began to defy expectations. As astronomers scrambled to study it in its brief window of visibility, they measured its brightness over time and found it was varying dramatically, swinging up and down as the object tumbled through space. The only way to explain such extreme changes in brightness was if Oumuamua had a wildly elongated shape, far more stretched than any asteroid or comet we had ever seen. The best estimates suggested an object perhaps several hundred meters long, but with a length maybe 6 or even 10 times its width. In other words, it was shaped something like a cigar, or by some interpretations, a flat disk, like a cosmic pancake. Nothing in our own solar system looks quite like that. The most famous artist impressions show a long, dark, rocky splinter tumbling end over end through the void, and that image seized the public imagination. Its color was another small piece of the puzzle. Oumuamua was distinctly red, a dark, reddish hue familiar from the frozen bodies of our own outer solar system. That coloring is the fingerprint of long exposure to cosmic radiation, which slowly darkens and reddens surfaces over vast spans of time. It was exactly the weathered complexion you would expect of something that had drifted through interstellar space, unprotected for eons. There was another clue in the way it tumbled. Oumuamua was not spinning smoothly like a well-behaved asteroid. It was rotating chaotically, tumbling end over end in a complex, unstable way, on a timescale of several hours. To astronomers, that suggested it had been violently knocked about at some point in its distant past, perhaps in the catastrophe that flung it out of its home system in the first place. It came to us already scarred by some ancient upheaval. So what was it? The natural first guess was a comet, since comets are icy bodies flung out of distant systems easily. But comets, when they near a star, warm up and release gas and dust, forming a glowing cloud, a coma, and often a tail. Astronomers looked hard for any sign of that around Oumuamua, and they found nothing. No visible coma, no tail, no obvious outgassing. By that measure, it looked more like a bare, rocky asteroid than a comet. But that raised a problem, because asteroids and comets are the debris of planet formation, and we expect far more icy comets to be ejected from other star systems than rocky asteroids. Finding that our very first interstellar visitor appeared to be a dry, rocky, weirdly shaped object, rather than an icy comet, was itself a puzzle. Oumuamua did not fit neatly into either box. And then it did something that deepened the mystery enormously. It is worth appreciating just how little we actually had to work with. Oumuamua was never more than a feint, even in our largest telescopes. No spacecraft visited it. No radar mapped it. We never saw its shape directly, only inferred it from the rhythm of its brightening and dimming. Almost everything we believe about this object is reconstructed from a scattering of measurements of a tiny, fading point of light. It is a portrait drawn from shadows. As Oumuamua swung away from the sun and headed back out toward the stars, astronomers tracked its motion with great care, and they discovered that it was not slowing down quite as much as gravity alone said it should. It had a slight but real extra push, a tiny acceleration away from the sun that could not be explained by the gravity of the sun and planets. Something was giving Oumuamua an additional, gentle shove. Now, for a comet, this would be no mystery at all. Comets get exactly this kind of extra push from outgassing. Jets of gas erupting from their sunlit surface act like tiny rockets, nudging the object along. That is the obvious explanation, except for one enormous problem. If Oumuamua was outgassing enough to push itself measurably off course, we should have seen that gas. We should have detected the coma, the jets, the debris, and we saw none of it. The push was there. The cause was invisible. The acceleration was tiny, but it was real, and it was measured carefully enough that it could not simply be dismissed as error. That is what made it so maddening. A comet accelerates and shows its gas. Oumuamua accelerated and showed nothing. Either it was venting some substance we could not detect, or it was being pushed by some other force entirely. Every proposed answer to that single question would prove strange, and none would be fully satisfying. This is the heart of the Oumuamua puzzle, a non-gravitational acceleration with no visible cause. And scientists have proposed a whole range of natural explanations, most of them exotic in their own right. Perhaps it was outgassing after all, but of a substance like pure hydrogen or nitrogen ice that is very hard to detect, releasing gas we simply could not see. Perhaps Oumuamua was made of something genuinely unusual. One striking idea is that Oumuamua might have been a chunk of a nitrogen iceberg, a fragment blasted off the frozen surface of a distant Pluto-like world, its nitrogen ice quietly sublimating to give that gentle push. Another suggests it was an extremely porous, fluffy object, a kind of fractal dust bunny far less dense than any normal rock, so light that the faint pressure of sunlight itself could nudge it. Each idea is strange, but each stays within the bounds of known physics. An earlier idea proposed a body made largely of hydrogen ice, which would sublimate invisibly and could also explain the missing coma. But hydrogen ice is so volatile that many doubted such an object could survive the long, warm journey through the galaxy without evaporating away entirely. Each hypothesis solved one part of the puzzle only to collide with another. Oumuamua seemed determined to resist every neat, complete explanation offered for it. One influential proposal, put forward in 2021, suggested Oumuamua was a shard of frozen nitrogen, chipped off the icy crust of a Pluto-like world in another system. Nitrogen ice sublimating gently in the sunlight could, in principle, supply the push while being extremely hard to see. Critics quickly countered that producing and delivering such a pristine nitrogen fragment across the galaxy seemed to require improbable amounts of raw material. Even the tamer explanations strained belief. And then there is the hypothesis that made headlines around the world. A prominent Harvard astronomer, Avi Loeb, argued that we should at least consider a more radical possibility. What if Oumuamua's gentle push came not from outgassing, but from the pressure of sunlight on a thin, artificial surface? What if Oumuamua was a fragment of a light sail, a piece of technology from another civilization, drifting through the cosmos? Loeb's reasoning was that a very thin, flat, artificial object could be pushed by sunlight exactly the way Oumuamua seemed to be, without any outgassing at all. It would neatly explain the acceleration and the lack of a coma. It was, he argued, a hypothesis worth taking seriously, given how many boxes the object failed to tick. The suggestion that our first interstellar visitor might be alien technology understandably caused a sensation. Loeb went on to lay out the argument at length in a widely read book, insisting that science should not flinch from the possibility simply because it made people uncomfortable. He pointed to the combination of oddities, the extreme shape, the missing coma, the unexplained push, and argued that, taken together, they at least warranted keeping the artificial hypothesis on the table. Whatever one thinks of the conclusion, he forced a genuine debate about how open-minded science should be. Now, it is important to be clear and careful here. The overwhelming majority of astronomers do not believe Oumuamua was an alien artifact. The scientific consensus is firmly that it was a natural object, however unusual, and that the exotic natural explanations, strange ices, or an ultra-porous structure are far more likely than technology. Extraordinary claims require extraordinary evidence, and the evidence for an artificial Oumuamua simply is not there. An international team of specialists reviewed everything known about Oumuamua and concluded, in a detailed study, that all of its observed properties could be accounted for by natural processes, without any need to invoke technology. Their verdict was measured but clear. Oumuamua was weird, yes, and not yet fully explained, but there was nothing about it that demanded an artificial origin. The burden of proof, they stressed, sat squarely on the extraordinary claim. But the reason the idea could even be debated by a serious scientist points to the real problem, which is not aliens. It is that we simply did not have enough data. Oumuamua was faint, fast, and already leaving by the time we found it. We got no close-up images, no detailed chemistry, only a precious few days of measurements of a tumbling speck of light. Into that gap of ignorance, every hypothesis, mundane and wild alike, could rush in. The mystery is real precisely because the data is so thin. A later reanalysis even challenged the famous cigar picture itself. By re-examining the way its brightness changed, some researchers argued Oumuamua was more likely shaped like a flattened disk, a cosmic pancake, than a long splinter. It was a humbling reminder that even the object's basic shape, the very thing everyone pictured, was never directly seen, only inferred, and could be wrong. We had turned a few flickers of light into a confident image that may not even be accurate. And that is the most frustrating part of the whole story. By early 2018, Oumuamua had faded beyond the reach of even our best telescopes, racing outward on its one-way journey. It is gone, forever, carrying its answers with it. We cannot go back for a second look. Everything we will ever know about Oumuamua, we learned in that brief, chaotic window in the autumn of 2017. The first interstellar visitor slipped through our fingers. Some scientists dreamed of chasing it. Studies were sketched out for a hypothetical mission, sometimes called Project Lyra, that might one day catch up to Oumuamua using clever gravitational slingshots. In principle, it is not impossible. In practice, it would be a decades-long journey to reach an object already racing away into the dark. For now, it remains a thought experiment, a wistful what-if about the visitor we met too briefly and let go. But Oumuamua was not the last. Less than 2 years later, in 2019, astronomers spotted a second interstellar object passing through, this one called Borisov. And Borisov was, in a way, reassuringly normal. It was clearly a comet, with a visible coma and tail, behaving just as an icy interstellar wanderer should. Borisov proved that interstellar visitors come in more than one kind, and that Oumuamua's strangeness was not the rule. Borisov behaved so much like an ordinary comet that, in a sense, it was less exciting and far more comforting. It showed that the galaxy does eject the icy, tailed comets we expected all along. That only sharpened the Oumuamua question. Why was our very first interstellar visitor the strange one, the dry, tumbling, accelerating oddball, rather than a normal comet like the one that followed so soon after? Perhaps we were simply unlucky, or perhaps lucky, to meet the weird one first. Together, these two objects, arriving so close in time, told us something profound. If we spotted two interstellar visitors within about 2 years, once we finally had telescopes good enough to catch them, then such objects must be passing through our solar system all the time. The space between the stars is not empty. It is thinly populated with countless drifting fragments of other worlds, and our sun sweeps some of them up as it moves through the galaxy. The numbers implied by 2 sightings in 2 years are staggering. They suggest that at any given moment, our solar system may contain a scattering of interstellar objects passing through, and that over its history the galaxy has flung out an almost unimaginable number of such fragments, perhaps more than the stars themselves. Every star that forms planets, it seems, also spits out debris, seeding the darkness between the suns with countless silent wanderers. And now the hunt is truly beginning. A powerful new survey telescope, built to scan the entire sky night after night, is expected to discover many more interstellar objects in the years to come, perhaps a steady stream of them. The next Oumuamua may be found not too late, but early, while it is still approaching, giving us time to study it properly, or even, one day, to send a probe to chase one down and see it up close. That is the real promise of the coming era. With a telescope that photographs the entire visible sky every few nights, the plan is to catch these visitors on the way in, not on the way out. Imagine spotting the next Oumuamua months ahead of its closest approach, with time to turn every instrument we have upon it, and perhaps to answer, cleanly, the questions this one left hanging. The age of interstellar astronomy is just beginning. So what, in the end, was Oumuamua? The honest answer is that we do not know for certain, and probably never will. Most likely, it was a natural object of a kind we had never encountered before, an exotic splinter of ice, or an impossibly fluffy fragment, tumbling in from another star. Its strange shape and its ghostly acceleration remain not fully explained. It is a genuine, unsolved mystery, and one we simply ran out of time to solve. And perhaps there is a kind of dignity in admitting that. Not every mystery gets solved. Sometimes the universe shows us something extraordinary, lets us stare at it for a few days, and then takes it back, leaving us to argue forever about what we saw. Oumuamua is a lesson in scientific humility, a reminder that the cosmos is under no obligation to arrive slowly, explain itself clearly, or wait for us to catch up. And there is real value even in the wildest part of the debate. The willingness of at least some scientists to ask, out loud, whether we might be looking at something artificial, forces us to think seriously about how we would recognize a visitor from another civilization if one ever did pass by. Oumuamua was almost certainly not that, but it was a dress rehearsal for a question humanity may one day have to answer for real. For most researchers, the enduring importance of Oumuamua has nothing to do with aliens at all. It is that a single tumbling rock forced an entire field to confront how unprepared we were, how thin our data was, how quickly a first-of-its-kind object could come and go. It sharpened our telescopes, our theories, and our humility all at once. The next visitor will meet a civilization that has learned, from Oumuamua, to pay attention. Because that is the deeper lesson of the scout from far away. For the first time, we held physical proof that objects from other star systems reach us, that the doors between the stars are not sealed. Whatever Oumuamua was, it came from somewhere else, from around another sun, and it briefly shared our sky. The galaxy, it turns out, is sending us messengers. We are only just learning how to catch them and how to read what they carry. There is something quietly staggering in that thought. The material of other worlds, forged around other stars, is drifting through our own solar system and occasionally sweeping close enough to touch our sky. Locked inside those fragments may be clues to how planets form across the galaxy, and even, some speculate, to how the ingredients of life might travel between the stars. Every interstellar visitor is a sample of somewhere we can never go. So remember Oumuamua, the first known thing from beyond to visit our corner of space. Remember that it came, behaved impossibly, sparked one of the great scientific arguments of the age, and left before we could understand it. And remember that it will not be the last. Somewhere out in the dark, right now, the next interstellar visitor is already falling toward our sun, and this time, we intend to be ready. Deep field exists to chase exactly these things, the objects at the edge of our knowledge that upend what we thought we understood about the universe. If the idea of a messenger from another star stirs your imagination, subscribe and stay with us. The cosmos is stranger and more crowded than we ever guessed. This has been Deep Field.